Hello students, I'm hoping that my voice is absolutely clear to you. Okay, so we'll start with the very interesting and very important topic, especially for the aspirants of who are planning to choose their career in 11th and 12th for science perspective. And also this is one of the most important topic for ICSE students as well. So in this topic we will talk about a few parameters. I'll just give you a brief about that. So we will be talking about electromotive force. We also be talking about terminal voltage, voltage drop. What exactly is this? And lastly, we'll talk about internal resistance. And based on these parameters, we will be covering a few numericals in this session, which are most relevant and would be capturing all the concepts related to this. So without further ado, let's jump into this part of the science. Okay, just spare a minute. I'll just open the chat. I'm hoping that my voice is absolutely clear to all of you. Okay, so let's So first of all, understanding what exactly is EMF. So EMF is basically, as I have compiled here in a definition, EMF is basically the maximum potential difference of a cell when there is no current in it. EMF is something, the maximum potential difference of a cell. So it is a property of a cell, and we'll learn about this later in the next slides also. And this is a property when there is no current flowing through it. So that thing is known as EMF. Or we can say this is the total energy supplied by the cell per unit charge, or we can say it is absolutely the potential difference to us. And this potential difference will be across the terminals when there will be no current flowing or the circuit is the open circuit. We already learned about these open and closed circuits. So now they are stating us that when the circuit is open, so this is something which is known as EMF. Okay, let's move on to the next topic, which is the terminal voltage. We'll cover these in detail also. I'm just giving you an overview of all the four things and how they are related to each other. So the terminal voltage basically is the potential difference when there is a current. So when there is no current or open circuit, so that is known as EMF, which is the maximum potential difference. But the terminal voltage is across the terminal, and the potential difference, it is something when the current is flowing through this, or we can say the circuit is being closed. So terminal voltage is basically denoted by capital V, and EMF is denoted by, sometimes it is denoted by capital E, and also by this symbol, which is epsilon. So these are the two notations for these things. Okay, let's move on to the next part. So terminal voltage can be across the terminals of the cell when the current is flowing through it, that is the closed circuit, and this is the voltage available to the external circuits. Actually, for the CBSE point of view, for most of the CBSE students, what you guys are going to learn is more related to the terminal voltage in class 9th and 10th, especially in class 10th, because in your class 10th we are not targeting electromotive force, but this is one of the most important foundation for your 11th class physics, and this formulation has to be understood in a proper way so that we can really target those concepts and those numericals. Especially there is an entire loop of concepts and chapters in electricity or electromagnetism domain in physics especially. So that's why it becomes one of the major aspect to control and to understand also. Now moving on to the third thing, which is known as voltage drop. So this is the voltage drop. So what exactly is this? When the terminal voltage is equal to basically the terminal voltage will also always be equal to the EMF minus this thing IR, where IR will be acting like a voltage drop, and this value of R, which is the small r over here, this is known as the internal resistance of the cell. So the resistance within the cells, electrolyte is a basic solution for the cells where electrodes are being installed, that opposes the flow of current. We know that all the resistances are something those are opposing the flow of current actually, and this thing is represented by a symbol small r. So in just introduction to these entire concepts, we have learnt about a few things. We have learnt about the concept that E is known as EMF. E is basically EMF, and I can just remove these things from here. Okay, so E is basically EMF. Okay, I is the, as usual, the current in the circuit. We are assuming, most of the time we would be assuming that not assuming, basically we would be targeting the questions related to in series. So accordingly we will have different things over here, and capital V is the terminal voltage, which is like our general voltage also, which we are using in the entire concept, entire chapter. There will be a small v, which is known as voltage drop, and there will be a small r, which is known as internal resistance. So these are a few things which we are going to target in this very chapter, in this very session, and let's jump into all the concepts one by one. As we discussed previously, that EMF is something when there is no current flowing in the circuit, so that thing is known as EMF, and we also call it as electromotive force. So this is the symbol for this, and this is how we have denoted it in an electrolyte solution. So the equation which is related to the EMF, because we need to understand these equations also, there will be different numericals related to them, and we have to understand all the relations between them, especially E, V, I, small v, R. All these relations we have to understand. So when W work is done in taking a charge Q around the complete circuit of the cell, then EMF is going to be W over Q, and the same formula we have learned when we were calculating the simple potential difference also, which would now be known as the terminal voltage. So there are two things now. Now we are dependent on EMF and terminal voltage. Two things would be there. So there are a few factors which are going to affect the this EMF also. So it would be related to the material of the electrodes, of which the electrodes are being prepared, electrolyte, and it is not dependent on the shape of electrodes, and it is not dependent on the distance between the electrodes, and also the amount of electrolyte. So it is just depending on the which solution is basically taken care of. So it will be dependent on that. A few examples of the EMF of different cells, like for a voltaic cell, the EMF is 1.08 volt. By the way, the SI unit of EMF, terminal voltage and voltage drop, these will be volts, because all of them are none other but potential differences or the voltages, and the SI unit for R, the small r, which is the internal resistance, it is going to be ohms. So we need not to confuse with these quantities. And for other cells also, the value of EMF is given over here. Now jump on to the next concept, which is the terminal voltage. So terminal voltage is something we understood when there would be some when the circuit is closed and there would be some current flowing through it. If you can just look into this, so you can understand that the current I is flowing through the circuit, and this is the resistance, which is the normal resistance. This has nothing to do with the internal resistance, and we'll talk about the internal resistance later. So the terminal voltage of a cell generally denoted by V. We already discussed this thing. And terminal voltage, basically what we have taken, that work done is taken to be W dash. For EMF we have taken the work done was W, and here the work done is taken W dash. What is the relation between these two, we'll understand it in the next few slides. But here on you have to understand that for EMF it was being written that W over Q was taken as the value. For terminal voltage it is taken that work done is a different value for the same charge. So accordingly, by these relations only we would be able to understand that because W and W dash won't be equal, they can be but they are not equal. That is by the value of E and V over here would be different values. So this we need to understand over here. So I am assuming that till now you have understood about basic concepts. What exactly is EMF, what is the terminal voltage, and what is the internal resistance, what is voltage drop. You have understood about them, and basic equations in relation to the work done and charges also you have understood over here. Now moving on to the next concept, and let us understand it in a few detail. That voltage drop over here also, you can see there is a different value of work done. So we know that voltage drop would be some voltage which is being dropped. Why is it so? Because of the internal resistance. So this is the voltage drop which will be carrying through this. So thus the work done in carrying a unit charge through the electrolyte is called the voltage drop. So this is something we should be knowing over here. Now the most important things we are going to understand. Till now we have learned about a few theoretical aspects, and now on we would be understanding the major relation between them and how they are going to how we are going to utilize them in the form of numericals. This would be our great target, and let's directly jump into that. So this is something which all of you have to learn very carefully, and if you have any questions till now, I'm open for a few questions. If you want to ask, you can ask. Okay, so let's jump to the next concept, which is what exactly is the relation between this EMF, terminal voltage, internal resistance, and voltage drop. So how we are going to take care of that. So I'm not planning to take you to the entire derivation or stuff, but I will be putting over here a few values. So by the law of conservation of energy, we are able to understand that this work done was equal to, this work done was basically the work done of the terminal voltage or the capital V, and this the voltage of the EMF actually, and this was for the terminal voltage, and this was basically for your voltage drop. So according to this, now putting the values of Q over here by dividing the Q in all the equations, we would be getting a value that is E would be equal to V plus small v. This would be the value, and by rearranging the values we can get different values as well. For example, if we need to find the value of this terminal voltage, it would be very easy. So terminal voltage will equal to E minus V, and if we need to calculate the value of voltage drop according to the formulation, so it would become V is equal to E minus V. So these are a few values, and by the way, we know the value of V also, that is I into small r, and we'll cover this thing later in the next few slides. So this equation is one of the most important equation for your numericals point of view, and all of us need to understand these equations so that we are able to conquer the questions accordingly. Moving on to the next concept, which is internal resistance. So internal resistance, basically it is the resistance offered by the electrolyte inside the cell to the flow of current, and this type of resistance is basically known as internal resistance because it is being offered by the electrolyte only, the internal solution only. That is why this resistance is known as internal resistance, and due to this we are able to understand, or there is a drop in voltage which is known as voltage drop, the same voltage drop which we discussed previously. And this is how we denote this thing. We just put these things in series to this, and this is the proper representation of our internal resistance with the circuit. And by the way, this is the value of V. Small v is equal to I into small r. This is the value of voltage drop, and the same current is being flowing through the entire circuit, and R is basically the internal resistance. So in the next few slides we'll jump about different aspects, and we'll talk about them in the next few slides. Now we have came across to the most important part of the entire discussion, and we already know the different values, and we already know different meanings of those values and concepts also. Now we need to understand and rearrange them in the form which is applicable to our questions, and this part is very important in that perspective. So here is a sample circuit which you can see, and in the sample circuit, as we have seen previously also, this is an arrangement of the internal resistance. Here you can find the EMF of the cell. This is internal resistance, and there is an external resistance also which is capital R, and the current is flowing through the circuit. So now we'll just talk about a few values one by one. So total resistance of the circuit is going to be very simple, because internal resistance will always be considered to be taken in the series to the entire set of resistance or the combination of resistance. So we just need to simply add this thing. So total resistance would be the sum of R arrangement or the combination of the resistances plus the small r, which is internal resistance. Why I've written R combination over here? Because of the fact that in this particular example which I have shown you, the value of R combination would be simply R. But when there would be some series or parallel combination of different resistors present in the circuit, so R combination's value is going to change. Now moving ahead, the current drawn through the cell will have the value of I is equal to EMF of the cell over total resistance. So this is the value of I from this equation. So we just need to focus, I just want you to focus on a few aspects. Right now we will just focus on the values of I. So one value of I is going to be EMF over R plus R. That is the total resistance of the circuit. Okay. Second value, as we know, the terminal voltage of the cell is equal to V is equal to IR. Why? Because of Ohm's law. Okay. So just putting this value. So based on this value, I would become V over R. Let me just put this value over here. So it would become V over R. Okay. And there would be another value also, because internal resistance is also there, no? And the voltage drop would be considered as, the small v would be considered at I into small r. Accordingly, I can calculate a value of I from this aspect as well. So it would become V over R. So let me just skip this part. So these are a few values of I, and based on the values given to you, you can calculate this according to your own will. And by the way, you would be surprised, I think not be surprised actually, all the values by different ways we are going to get the same value of I. If we are provided with EMF and we are using this formula, we would get the same value of I. If we are using this formula, we would also be getting the same value of I, and similar would be the case here. So this is very important in that aspect. And because we know there are different parameters also, so we can also calculate the value of internal resistance from this part. Let us just understand this in detail also. So R would become, accordingly, R would become small v over I. Okay, and we know that small v value was equal to E minus V, because E was equal to V plus small v. So accordingly, the value of V had become this. So I am just replacing the value of small v over here, that is voltage drop. So it would become E minus V over I. Okay. So our target is to take this value in three parameters, take the value of internal resistance just in three parameters, that is EMF terminal voltage and the net resistance or the total resistance. Not the total resistance, I mean the net resistance apart from the internal resistance. So how we can make this into account? We'll just for I also, we know that I's value is V over R, because we need to replace the value of I from this part and get the value of R. So E minus V over I would become V over R, and accordingly if I take V into common, so it would become E over V minus 1, and I'm taking R as common, so it would become something like this. So this is going to be the final value for our equation. So these equations, why we are taking these into why these relations are being taken care of, because these will be required as it is or maybe in other form as well. So now we would be having a question over here. So there is a question which is high resistance voltmeter is given, and we have to measure its potential difference. So this is your question. You may just read it and try to solve it. And I am giving you 2 minutes for this, and after that we'll do it. Okay, so let us solve this question. Let us first understand what values are given over here. So there is a high resistance voltmeter, measures the potential difference across the battery to be 9 volts. Okay, so EMF is given to us and the value of EMF is 9 volts. Okay, and on connecting a 24 ohm resistor across the terminals of a battery, because R is given to us, which is the combination of resistors, and the value is 24 ohms. Okay. Across the battery terminals, the voltmeter reads 7.2 volts. Because the voltmeter reads the terminal voltage, so our V would be 7.2 volts. Now we are supposed to calculate the internal resistance of the system. So accordingly, we already know the different values of calculating this thing, and in the last slide itself, this relation would be very applicable over here. And let us just directly put different values and get the answer here. So E over V minus 1 into R. So this will be the value of our internal resistance, and let us just put these values together. So 9 over 7.2 minus 1 into 24. So while solving these values together, we would get an answer which would be 6 ohms. So our internal resistance will be 6 ohms based on the concept. Okay, now moving on to the next question. So this is how the value of internal resistance would be according to this. Now moving on to the next question. There is a battery of voltage 12 volts which is producing a current of 400 milliampere. We need to understand about these SI units also. And okay, so after long continuous use, the current drops to this value and the appliance does not operate. We need to find the resistance of the appliance, terminal voltage of the battery. When the appliance stops operating, voltage drop, internal resistance of the battery. So these parameters we need to answer over here. So I am again giving you 2 minutes for this to understand this question, and then we'll directly jump into the solution for this. Okay, so let us understand this question. We are given a value of EMF which is 12 volts, and the current is given to us which is 400 milliamperes. First of all, we need to solve the value of current, and it would become 400 into 10 raised to the power minus 3 amperes. While solving this, I could get a value of 0.4 amperes from this equation. Once we are done with this, so the first part is to calculate the resistance. So R would be equal to EMF over current, which is 12 over 0.4, and the value of resistance would be 30 ohms from this equation. And the second part is we need to find the terminal voltage of the battery when the appliance stops operating. So we know that after the prolonged use, let us say the new current value would become 320 milliampere. Let's say it becomes I dash, and while solving this we could get a value 0.32 amperes from this, and terminal voltage of the battery would be V is equal to I dash into R, where R is already given to us and I dash has been also given to us. So it would become 0.32 into 30. So the value is going to be this, 0 would be calculating from this, and okay, so 9.6 volts would be our terminal voltage. So while terminal voltage is there and also EMF is there, so third part is quite relevant and very easy to calculate. So I am assuming all of you would be able to calculate the third part over here, which is voltage drop. So V would be equal to EMF minus terminal voltage. EMF was given to be 12 volts and terminal voltage is 9.6. So this would become 2.4 volts. And the later things, the last part is internal resistance. So internal resistance would be R would be equal to the voltage drop over the net current, which is going to be, internal voltage was 2.4 volts and net current's value was 0.32 ampere. So calculating these values together, I can get an answer. So it would come to be 7.5 ohms. So this value we are going to get from this equation. So this is how we are supposed to make answers to these questions. And there is one more question which you can use, a somewhat similar question, and this could be used as a homework for you, and you can just solve this question and make an attempt by your own. This is very simple question. Let's jump to the next question, which is a little bit tricky, not exactly tricky, but a practical question from this very concept. So there is a cell of EMF 1.5 volts, and we are also given an internal resistance which is 1 ohms, which is connected to this. So I am assuming that just have a reading of this question, and based on that we'll understand the various concepts which are related to this. There are two resistances, that is 4 ohm and 20 ohm, which are connected in series. So first of all we need to find the current in the entire circuit, potential difference across each resistor, potential difference across the cell, and voltage drop when the current is flowing. Okay, so let us solve this question. Initially we need to find the current in the circuit, and we know the value of current is EMF over the total resistance in the circuit. So first we need to find the value of total EMF in the entire circuit. Let us assume that this is the value of, let's take the value capital R as this particular thing, and it would become R1 plus R2 plus internal resistance. So by putting all these values together, so 4 plus 20 plus 1, it would become 25 ohms. Now putting these values together, so EMF is given to us as 0.6, I'm sorry, So EMF was given to us as 1.5 volts, and the value of net resistance was 25 ohms. So we'll just solve these values together, and it would become 0.06 amperes. So the current's value is 0.06 amperes, and this will be the entire current which is going to be flowing in this circuit. Okay, now moving ahead, and I'm just erasing this value over here, and we'll just keep the value of current from this. So I is equal to 0.06 amperes. Okay, now finding the next thing, which is the potential difference across each resistor. When each resistor is being called, we are not asking for the potential difference across this, the internal resistance. If we need to answer this, so it would be asked differently, like voltage drop. So this would be voltage drop when potential difference across different resistors is being asked. So we need to follow these two resistances for that part. Okay, so it becomes very easy. We know the value of V1. Let's say this is V1 is equal to IR1, and this is V2, which is equal to IR2. So V1 would become I1, I is equal to 0.06 amperes, and R is 4, and V2 would become 0.06, and R was 20. So accordingly, while calculating these two together, we would get a value of 0.24 volts, and for this part we would be getting a value of 1.20 volts. These are the two values which we will get from this. Now the next part is they are asking, so we have done these two parts. Next part is they are asking the potential difference across the cell. So this potential difference would be the total potential difference actually. So total potential difference, or I can say this V would be equal to V1 plus V2, and just putting these values together, so I can get a value 1.44 volts. So this would be our net potential difference, or the total potential difference across the cell. Now calculating the last part, which is the voltage drop. Voltage drop we can calculate by two ways. One is V was equal to I into small r. So we can calculate it by this, just putting the values together. 0.06 into 1, that is 0.06 volts. So this is one of the method, and second method could be by the V is equal to E minus capital V. So RE was 1.5, which is given over here, and this is our terminal voltage, so 1.44, and by solving this I can get a value of 0.06 volt, which is absolutely the same value as we have achieved previously. So my dear students, till now we have understood about a few concepts and a few questions. I have also given a question for your homework, so you can just take a screenshot of this and practice by your own. And I am assuming that all the concepts, all the questions related to EMF, terminal voltage, internal resistance and voltage drop have been taken care of. And if you still are having any doubts, so the comment section would be open, and I would try to take all the answers in the next session. And till now also you can check for all the other videos which are being provided in the channel, and it would be great if you can subscribe us and understand all the concepts based on our parameters, which we really try to help you. So all the best for your journey and your classes ahead. Thank you so much.